Hello all, welcome to the project Customer Personality Analysis. So now, during the course of this project, we will learn about primitive machine learning techniques used in clustering project. So basically this is a kind of clustering project in which we are finding out or we are analyzing the personality of customers, like how these customers are, what are their habits and what are their views on their product, and then we'll try to segment them. So we'll try to do the same using two different approaches. So again, we'll be performing this operation with two different approaches. This project will give you an idea about the steps done in a machine learning project. Basically, what we'll do, we'll first do the data analyzation or data processing. We'll do some feature engineering. So this will give you an idea of how machine learning project is done. So now, but what is the motivation or what is the main reason we are doing this project, or what is the importance? So as written, customer personality analysis is a detailed analysis of a company's ideal customers. Okay. Obviously, it will help the company to grow and understand its customer and makes it easier. Basically, understand it in the kind of uh, it understands it a kind of feedback system, like you are giving out or taking out the feedback from the customers. Okay, so this is a kind of feedback system which will help us to modify our product according to a specific need. So customer personality analysis helps a business to modify its product based on its target customer. So as I said, suppose we have an example, like instead of spending money to market a new product to every customer in the company's database, a company can analyze which customer segment is most likely to buy the product. Okay, now this is how you can proceed. Like instead of selling this project to every other person, we can just segment a group of people whom we are very sure that okay, these people will buy the our product. So this will save our time, money, and improve our productivity. So now we'll be performing exploratory data analysis for in this project. Like we'll be performing or plotting some figures, answering questions like what is the age distribution of customers, what is the education level of customers, the income of customers. We'll find out the relation between different parameters. Okay, what can be the relation between them. Then the data set. Okay, the data set which is here is taken from Kaggle. I've taken this data set from Kaggle. So I have planned to do this project in two different ways. Okay, we'll try to first perform the clustering using elbow method. In K means clustering, there's a method called elbow method in which we find out the optimum number of Ks. I'll tell you how to do that. Then we'll try to use, or we'll see that if we can use supervised learning algorithms to do this or not. Basically, clustering is an unsupervised algorithm, you don't know the results. So we'll also see that if we can use the supervised algorithms in this to bring results. So finally, the timeline of the project will be something like this. First, we'll be importing the libraries, then a little data analysis, some feature engineering techniques, then we'll be performing the clustering. So let's begin and proceed to the notebook section. Hello all, and welcome to the notebook section of this project. In the customer personality analysis, as in the introduction section, we have seen that what is customer personality analysis and how it can benefit the company. We saw that okay, if we do the customer personality analysis, we can kind of cluster our customers, or we can find out the right approach to sell our product to the customers. In the example, I said that if we can analyze which section of the public will buy our product the most, so we'll focus on that section only, then we'll leave the rest because it will give us no profit. Okay, so now let's proceed. The timeline I have discussed, the importing libraries, data analysis, cleaning, clustering, the usual. Now the libraries which are there are, let me show you. I'll just restart the kernel. Now the pandas and the numpy. Now pandas, I've already known that pandas is used for basically analysis, and numpy is used for computational ability, to basically to do some mathematical operations or all of those sort. Okay, Cvon is already used for visualization as the matplotlib. This is for visualization. Okay, this for visualization. So now these are the very simple or the basic libraries that will be required. So let us see a data set. Okay, so this is a data set which I have taken from Kaggle. It is under the operation of the notebook, customer or customer personality analysis. The name of this data set is marketing campaign. I'll just run it. The name of the dataset is marketing campaign. Okay, so let's just see the dataset. Okay, so as you can see, we have ID, year birth, of the customer, ID of the customer, education, marital status, income. Is there a kid home? Kid home means how many kids are there? Like the kids ranging from 1 to 12. Okay, that will be kid. Then teen, the 13 to 18 will be the teen. DT of customer, like the date of the customer purchase, recently, wines and num web visits per month, accepted CM3, accepted CMP4, and all of these things. Okay, so these are the different executive, but there are 29 columns. Okay, it is not showing up because I have not done the option of pd dot set max. Then you can write column. You can do that in order to basically see all those. Now if you want to see the columns, df dot, we'll write df dot columns. So these are the columns. In this we have some z revenue and z constant, accepted CM, all the basic or the basic criterias. And we'll just see the shape. Okay, so we have 2240 samples. Okay, we have around 20 to 40 customer data with all these columns, so which will tell us detailed information. So as we have seen the data set, and we have seen that what are the different, basically the main things are these only. Okay, what is the education level, marital status, what is the income. Because see, like problem, like if we choose income. Okay, so income, if the person's income, you are selling a product which is a little expensive, it's a costlier one, so it's obvious that a person which is having a higher income will only buy that. So it is very much logical to not approach the person which is having a low income. So by that you can customize or you can segment your customers. Okay, you can segment your approach, you can make your approach. So this is where this segmentation helps. And then now we'll be doing some data analysis on this whole data set in the next section. So let's move forward. Hello all and welcome to the next section of our project. So now in this section we'll be doing the data analysis. Okay, in the earlier section we have seen the different libraries and we have understood why we are using it. So now let's see, we have seen the shape. We have 2240 total of customer data. So let's see what the variables are. Like many of the variables are int, obviously, because the date is only the object and income is float. Rest of all are, I think, integer only. Yes, all of these are int because all are in the binary digit number. So we should see the data types also the same. Okay, the info will show you the same thing. Okay, it will just show you the same thing. It will just showing you the whether it is int or object or float. So now let's proceed with the data analysis. Now the very first thing which comes in your mind when you do data analysis is null values. Let us see if we have any null values or not. So we have a little in income, df dot is null dot sum. You can do that. So you can either drop these null values or you can leave them, because okay, let's just convert or let's just replace these null values. Okay, I'll just say df dot df income is equals to df income dot fill na. I'll just write here, I'll say mean is equals to df income dot mean, and I'll just say fill it with me. Okay, I have to write this in this way. Okay, so now let us see if we have removed our date null values or not. Okay, so now what I have done is I have removed or I have replaced these null values with the mean. So this is one of a way to basically remove or handle your null values. Either you can drop them, but we have a very less data, so that's why dropping these will drop all the complete row, so we cannot afford the loss of data. So it is a pretty safe way to basically replace this value with the mean as it was a float. So now what we are doing is we're creating a new column called age because we don't have the age, and age is a pretty important criteria. It is very simple. We'll just minus the date of birth with the 22. Okay, it will give us the today date. This is very simple logic. So now let us see the distribution plot. I've created the age table. If you want to see df age, so this is my table 65, 68, and all of those things. So let us see the distribution. Okay, so I have used the distribution plot from SNS Seaborn. So as you can see, most of the customers are lying between 40 to say 70. Okay, but majority of the customers are of 40 to 60 age group. Okay, 40 to 60 age group. And let us see the education. Okay, what I'll do, I'll just say the value counts, or I'll say what is the education, what is the majority, or which education is in the majority. I'll just draw pie chart. I'll just use plt.py. This is a basic command we write, and ed is basically the value counts or the data which I am giving. If we'll just see what is this thing is doing, this is just giving me the numbers of the education column. Okay, as you can see, we have 5 graduation. Most of us are graduated, then phd, then master, then second cycle, then basic. So we'll just do this, or we'll convert this into a pie chart. Okay, so this is the pie chart. So as you see that most of us are in the are graduated, then very the few of us then have the PhD. Like from this data, we can see that most of our customers are very highly educated. At least they have graduation. Okay, and then they have a very good number have PhD also and masters. So our customers are very educated. So now let us see the marital status. Okay, what is the marital status, if they are married or not? So as you can see, we have several things: single, together, married, divorced, widow, alone, absurd, YOLO. Okay, these are kind of fun type options. So obviously no one would be there. Widow status, like if the person is a widow, if it is divorced. Married is the highest category, then they are together, that means they are living together like in a live-in or kind of thing. And single, together, and married make up the majority of our customers in the marital life. Now the next thing is income. Okay, this is a very important thing. Okay, we are plotting a distribution plot. So as you can see, almost 95% of our income lies between 0 to 1 million. Okay, sorry, when 1 million. Okay, 1 million, 0 to 1 million. Okay, so it's just 1 lakh. Sorry, it's just 1 lakh, not 1 million. 10 lakh is 1 million. It's 1 lakh. So basically, most of our customers are lying in this range. Or we will see a very short range lying in around 1.5 lakhs. So this is pretty much, I'm sure it is dollar, so it is a huge amount. So let us see if there are any kids home and teen home. Like if I've said earlier that kids home means the children who are between the age group of 1 to 12, then teen home is 13 to 18. So let us see. So as you can see, 0, that means there are 0, no kids, and most of us is one kid, at least one kid present in kind of the range from 1 to 12 years old. The one kid is present. 2.1% is a very less for a two kid, but majority 0 and 1. So similarly with teen is also the same case, 1 or 2. So it is obvious most of the families have only 1 or 2 children. Okay, they usually have a gap of 3 to 5 years, so it is pretty common. So let us see now the correlation between different parameters. Okay, I'll just plot a heat map with passing df dot correlation. So as you can see, this is my correlation, and how these labels are correlated with each other. So that is a very big matrix because we have very much labels. Okay, so this shows us the color scheme for the correlation. You can pause and have a look at how these methods or the parameters are correlated with each other. And the next thing is we'll be plotting a scatter plot between different columns, like what is the relation between income and minimum fruits and meat products and fish products. So what is the relation between the income for that? So it is very obvious that if a person is having a higher income, it will obviously take that. Okay, but in this case, most of us are equally distributed. Like in all of the case, we can't see any much difference. All of these are same, a little bit difference only. So now what the last thing which we'll be doing is we'll be seeing the education and income basis. Okay, we'll just plot a bar graph based on the income. What is the education? So the highest education is obviously, highest income is obviously the PhD student. Then the graduation and masters are almost the same. Then second cycle and the least is the basic. Basic probably means the 12th standard. Okay, this is the pretty least. This is the basic. So from this we can see that PhD, graduation and master are the highest earning, and they should be the proper target for our customers, okay, for our product if we are using a high-end product. So this was the data analysis part. So now in the next section what we'll do, we'll be performing some data cleaning and feature engineering section, so which will give you an idea of how the feature engineering is done and how we can approach for it. So let us move to the next section. Hello all and welcome to the next section. So now in the previous sections we have seen that we have done some data analysis and we have seen what is the income or the basically the questions which we discussed in our introduction section. Okay, what is the age of the section, what is the income, and what majority of our population, how is the education, and what is the income for it. We have done all of those things in our data analysis part. So now in the next section, what we'll be doing, we'll be performing or we'll be doing data cleaning and feature engineering. Okay, we're doing some data cleaning and feature engineering. So the very first thing is we'll be dropping NA. So but earlier also what we have done is we have replaced the null value or basically the value which we had. What we did here, I'll just write here. We replaced the income null values with average or mean of income. If you want to see what was the mean, I'll just write here mean because that is what the name I stored. Okay, mean was around 52,247. So all of those 24 null values were replaced by this value. Okay, so probably there will be no null values. Okay, no null values are there. So let's move forward. What we'll be doing, we'll be creating an extra feature. Earlier also we created an extra feature called age. So now in this section, what we are doing, we are creating a feature called total spent. Okay, total spent will give us an idea or basically a thing like how many are the total spent of what procedure or the what how the spendee spend, how our customer is spending our data. Okay, so we'll just add all the different products or the expenditure in wines, in fruits, in products, in fish products, if how it is spending. Okay, we'll just spend if the function, if the customer is spending on wines, if it is spending on fruits, if it is spending on meat products, and all of those things. Now the next three thing what we'll be doing is we'll be creating something called relation. We will just, this very simple thing is we are, what we are doing is we are just kind of label encoding what we are seeing, replace married with two together with two. Okay, because if they are married they are two people, if they're together they are two people. Rest absurd, widow, YOLO, divorce, single, alone, all of these are one only because he is right. Then the children in this will be saying that add the number of kids and number of the teen. So by that way what we have a family size total column in which we are actually adding the relation plus children. Okay, that give us a total family size. So if you'll just see df, now what we are doing, then we'll just drop our two relation and children because we have created something called family size, so these two are of no use. So we'll just say df dot drop. I'll just write relation and children. We'll just put a comma and I'll just say access equals to 1. Okay, it is saying Relation not found in Axis. Relation not found in Axis. Okay, I've written the spelling wrong. Okay, so now if we'll see the columns, df dot columns. So we have family size, but we don't have anything called relation of children because we have removed them. Okay, so now the next thing is we are label encoding the data. We are label encoding the data. For that, I am just using label encoder which will do hot one hot encoding, and the standard scaler, it will just scale the values based on mean of the data. So one label encoder will just label encode. So if you want to see the education, graduation, PhD, so what we'll do, we'll just label encode. It will just assign some value to it. Okay, label encoder is not defined. I have to just do this, then it will just do work fine. Now if I'll just see df and education, so we have encoded the data, like the graduation is 2, and kind of I think PhD is 4. Yes, PhD is 4, and like that. Okay, like that the label has a label encoding has been done. So now, like what I'm doing, I am just dropping the total. What we have done is we have created a total expenditure. So we don't need these columns. Okay, we don't need these columns. So I'll just drop them. I'll just drop them, and I'll just say df1. Okay, this is my df1 because I have copied. So this is my df1. Now what I'm doing, I'm just scaling the values. I'm just scaling the values. Okay, they are saying that. Okay, okay. So basically, there is no need to scale because all of these values are in a binary digit only. Okay, so we'll just skip this thing. We just skip this thing, although it can't scale because it has date included. So we'll just skip this. We don't need actually the scaling because we only have a little bit column which will just do fine in clustering. Basically, the scaling is required wherever we need to find out the distance. Okay, so now that is why scaling is required, but here most of the columns are in binary number, so we are not doing scaling. If you want to do, what you can do, you can just remove the DT customer column and marital status, because obviously it cannot scale, it can only scale the integer and float objects, right? So we'll just remove them and scale them. If you want, you can do it, then you can see the results. Okay, now we have done the feature engineering part. Okay, we have done the feature engineering part. We have seen the data analysis part. Now it is time to perform clustering. That we'll be doing in the next section. Hello all and welcome to the next section. So now in the previous section we have done the data analysis for our project. We have done the data feature required feature engineering. Now we are performing clustering. So now if you see that I have told you that we will be performing or doing this operation or project with two different approaches. So now the first we are using is we are using unsupervised learning. What I'll just write down, we are using unsupervised learning. Approach 1, unsupervised LEAR learning. Okay, so now as it is seen, we have a column in df dot response. Okay, in this, if the function or if the customer has bought this project, it is 1, and if the customer has not bought this project, it is 0. So now this is a kind of dependent variable, but in the previous section, in this section, what we have done, we have dropped this variable. Okay, we have dropped this variable, as you have seen, because we are making it as an unsupervised model. In unsupervised learning, we don't know what this output is. So we are trying to cluster our customers on the basis of the information we have. Okay, so now what we'll be doing, we'll be using elbow method. If you don't know what elbow method is, I'll just show you. We'll just write here the elbow method. We just connect. So basically elbow method is nothing but in this method we'll just see that, okay, what is the optimum number of k's we required in a k-means clustering. Elbow method k-means. So WCSS is the sum of squared distance between each point and the centroid in a cluster. When we plot the WCSS with the K value, the plots looks like an elbow. The K value corresponding to this point is the optimum K value or an optimum number of clusters. So now, as you have seen that what is K-means clustering, K-means clustering basically does is it classifies or it clusters the data on the basis of the number of clusters. So this elbow method helps us in finding the optimum number of clusters. Okay, so we have a module called K elbow visualizer, which will just find out the optimum number of clusters for us. It will automate the process. Otherwise, we have to write the code. We have to perform clustering. We have to create a for loop, then perform clustering, then draw the graph and find out the optimum. But in this, we are using k-means and scalar metrics, then agglomerative clustering. This will not be using, we'll be using k-means clustering to get a simpler view. Okay, and k elbow visualizer is the thing we'll be using. So I'm just dropping my marital status in DT customer because it will just not read the object one. Okay, now I'm just creating this. What I'm saying, em k elbow visualizer. K means is the basically the kind of application or the method we are using. Okay, and k is equals to 10. Then I'll just fit with my data frame. Okay, fit my data frame and then I'll just show. Okay, the optimum number of clusters is k is equals to 4. Okay, k is equals to 4 because after the error or the distortion score is drastically reduced till 4, then it is slowly reducing. Okay, so k is equals to 4 is our optimum number. So let's just create this with k means. I'll just say k means n cluster is equals to 4. I'll just predict k means fit dot predict. I'll just create a new column called df clusters. If you want to see what this df clusters is, I'll just write df and clusters. So these are the different clusters. 4 clusters are made as we have written. If we would have written 2, then it would have made 2 clusters. Well, let's just visualize it. I'm just giving different color patterns and I'm just creating x is equal to df clusters. I am creating a count plot. So the maximum number of clusters created is between 0, 1 and 3. And this second cluster may be of outliers or basically a different outliers or the people which are having a very high income. Okay, maybe these are them only. Then rest of all we have 3 main clusters. We'll just plot a scatter plot for them with the total spent income clusters and we'll see that what is the results. If you see that based on this our clustering has done a pretty good role in this. What we are seeing at the income. So okay, let's see the first cluster, the one part, the income. This person belongs to the category with high income and high spending. The purple one, the zero category, belongs with medium income and medium spending, and the red category belongs with less income and less spending. So this is kind of clustering a model has done. This could be a lot better, and this is obviously a second cluster which is the outlier, which is a very high income but very less spending. So basically this is probably an outlier. So this is the kind of clusters. This would be a pretty good or a good more model if we would have done a bit more of feature engineering, which I have told is scaling down the values and doing a bit more. But this is it. So this was the unsupervised method. So now the next thing what we have to do is we have to perform supervised learning. In this, what we'll do, we'll just use different parameters or different we'll just use different methods like the decision trees and different models, and the independent variable will be our all these features and dependent variable will be our the response. So that is in that way also we'll see what is the accuracy. So that will be a final section. So let's proceed. Hello all and welcome to the last section of our project. So now in this section what we'll be doing, we'll be performing the supervised approach. Earlier we have done the clustering approach using the k-means clustering, that is the unsupervised approach. So now in this section what we are doing, we are doing a supervised learning approach. I'll just write here approach to supervised learning. So now what we are doing, we are creating a dependent independent variable. This is a dependent variable and these is our independent variable. I have told you earlier why and what is response and how is that a dependent and independent variable. Basically response is the one that means the person has bought the product, zero that means it's not. We'll just split the data using train test split, and this is a X train shape, Y train shape. So now the first model we are using is the decision tree classifier. The decision tree classifier, I'll just write decision tree. So in that what we are doing is we are using importing decision tree. We are just class fitting the model. Then we are just obtaining the score. We have a score of around 0.81, 0.81%. Okay. So we have, this is a very short demonstration of a model. Okay. Because we have done the main clustering. I'm just trying to show you that we can also do this using a supervised approach. But in order to do that, we have to have an output. So that is basically not a result in the kind of, that is not the case in the kind of this problem. It's basically just a kind of a sideways in which we have a result, then we are performing clustering. We are on the basis of the optimized result, so that we can predict if we have a data for customer, then predict okay this customer will take the product or not. So we have an accuracy of 0.81, that's 81%, which is pretty good. Now in the next thing what we are using is we are using k nearest neighbor. What we are using? Using knn. I hope you know what kn is. Very simple. I've written nothing. I've just imported k means k nearest neighbor. I'll just say knn, the neighbors is 5. I'll just fit it and find out the score, that is 0.85%. So now the last thing also what we can use is we can use a random forest model. I'll just show in front of you random forest. I'll just say from sklearn dot ensemble import random forest classifier, sklearn. Okay, so now I'll just rf is equals to random forest classifier. Okay, I'll just say rf dot fit. I'll just give the parameters xtrain and ytrain. Okay, I'll just say or find out the score between the scheme. Okay, I'll just say pred is equals to rf dot predict, and I'll just say ytest. Okay, sorry. I'll just write out the score. I'll just say rf dot score, and I'll just say x test and y test. We have 0.89. These are very common general scores of how these models will perform. I have not implemented them completely. I will leave them up to you. You'll just you fit the model, perform some feature engineering again in this. Although we have done the feature engineering for our clustering, but we have done that for a clustering model. You perform this on the basis of solving a supervised model problem, then you will obtain the results. So we have what we have done, we have done the unsupervised approach, that is the clustering. We have done the supervised approach in which we have used decision trees, knn and random forest. So I'll be providing you the data along with this notebook. Take this reference and do the project on your own and find out new possibilities what you can obtain. I hope you enjoyed. Thank you.